In this video, we'll be exploring the meaning of rational exponents. And what do I mean by rational? I just mean an exponent that's a fraction. Alright, so let's say we have 25 and we raise it to the half power. Well, to the half power probably doesn't mean that much to you yet, but it will in a few minutes. Well, if I take this and then I raise that to the second power, well, we're getting closer to something that might mean something to you. Now, remember back in the day when we looked at the properties of exponents, the laws of exponents? I'll put this over here. A to the B to the C is really equal to A to the BC. Like, that's the whole thing, right? If we are raising a power to a power to a power, we multiply the exponents. Well, power to a power, we're going to have to multiply the exponents. So 25 to the half times 2, same thing. So this is really 25 to the 1, which, of course, is really just 25. All right, so what's the point of all that? Well, this whole thing is just 25. So this part here, inside the parentheses, when you square a number, well, when you square this number inside the parentheses, you get 25. So inside the parentheses, or 25 to the half power, is actually the same thing as the square root of 25. I hope that wasn't too much for you, but just in case it was, here's the deal. If I have, let's just call our number, oopsie, let's press on a pen first. Okay, let's call our number B, and if I raise it to the half power, it's the same thing as square rooting it. If I take my B and I raise it to the third power, it's the same thing as cube rooting it. I can go on and on and on and on and on and on and on. And I won't because I ran out of space. But here's the thing that you need to know. The denominator of our exponent is the same as the index of our radical. That's the rule. The denominator of the exponent is the same as the index of the radical. So we can write that down as something to remember. So the denominator of the exponent is the same or equal to the index of the radical. Alright, so I have a little bit more to show you, and then you'll understand all about these rational exponents. Okay, so from what we just did, you should know what 8 to the 1/3 power is. 8 to the 1/3 power is just the same thing as the cube root of 8, which, what number, when multiplied by itself 3 times, gives you 8? Well, that number is 2. So that is just 2. All right, so let's get a little bit more daring here and put a number other than 1 in our numerator. So what does this mean? 8 to the 2/3 power. Well, going back to the laws of exponents, we know that 8 to the 2/3 power is really just 8 to the 1/3 power squared, right? 8 to the 1/3 power squared. Because, of course, we know that we can multiply 1/3 and 2/3, 1/3 and 2 and get 2/3. Okay, and we already know that 8 to the 1/3 is actually the cube root of 8. So 8 to the 2/3 is that value squared. All right. Hopefully you're following, but if you're not following, I'll show you a bunch of examples and you'll get it. All right, what does that mean? Let's bring our B back as a general example. So let's say we have a number B and we're raising it to the power of x over n. All right, so we already spoke about the fact that our denominator will be our index here. So we know that this is the nth root. However, what is the b? Well, the b is the big number. That was not intentional. All right, but the b is the big number. It goes under the radical. And our x is the exponent, the power that it's raised to. See, here, our x was 2, and our exponent ended up being 2 on the outside. Same will be for this case, or x will be the exponent. Now take a look at this. In this case, I put the exponent outside of parentheses. Over here, I put it inside the radical. It doesn't matter, actually, if it goes outside of parentheses or inside the radical. It could have gone outside of parentheses here. All right, so let's just look at a bunch of examples just to make sure that you're absolutely comfortable with this. So we have here the example that we did before, 8 to the 2/3 is actually, the big number goes under here, or 8, or 3 is the index, and our exponent here is 2. All right, so let's try a couple more. How about 9 raised to the 3/2? Well, here we go. Our big number is the 9. Our index is the denominator, which is 2. And our exponent is 3. So there we have it. That's how you'd set this up. You can do this also for any variable. It doesn't matter what the variables are. So let's say we have x to the a over b. Our big number is x. Our denominator is b. And our exponent is a. So I notice I switched the letters up here. The b is playing a whole different role than it did in our example before. And the x is playing a whole different role in our example from before. But it doesn't matter. What does matter is that our denominator is the index, our big number remains the big number, and our numerator is our exponent.